we're going to look at graphing tangent and cotangent and transformations and all that fun stuff. But we're going to start off with tangent. So already up on the screen, I have tangent of x, and this is the graph of tangent of x. It looks a little weird, and it looks scary, but we're going to dissect it a little bit and understand it. So the first thing to notice is it's repeating. It's also a periodic function. It repeats. Now, for sine and cosine, that's between 0 and 2 pi. For tangent, it's actually just from negative pi over 2 to pi over 2. Now, that means that this function, tangent, is periodic over pi. So from one end of tangent, that graph, to the other end, it is pi. To demonstrate this, I will show these asymptotes. So there are asymptotes. So this is negative pi over 2. This is pi over 2. The distance between these two, pi. So it takes pi amounts of time, let's say, to repeat this function, whereas sine and cosine is 2 pi. Anyways, another key point is our midline. So don't forget that midline is still at y equals 0. Here I have it graphed, center of our function. And now there's, again, critical points, if you want to call them that, for this graph. So remember that tangent of x is just, you take the sine of that x value and divide it by the cosine of x. Now let's say if we had tangent of 0, well, that just means sine of 0 is 0 over cosine of 0 is 1. You can use your unit circle to prove this, use a calculator. 0 divided by 1 is 0. So that is where this point on our graph comes from. You plug in 0, you get 0 as an output. Now the other 2 points, if you think about it, remember on a unit circle, when we plug in tangent of pi over 4, that's sine of pi over 4 over cosine of pi over 4. Well, pi over 4, both of these are root 2 over 2. So this fraction becomes root 2 over 2 over root 2 over 2. Now you can, turn them into fractions, keep, change, flip, do all that fun stuff. Or you can just realize, well, I have the same number in the numerator and the denominator. So if I divide them, I will get 1. Right? Like 3 over 3 is 1, 5 over 5 is 1. In this case, root 2 over 2 over root 2 over 2 is just 1. So that is where this point comes. This point, we have pi over 4, and our y value is 1. You can see it right there. We can erase this. Now the same is true if we plugged in a negative pi over 4. Nothing changes except the sign. So that's where we get this last one. After that, it follows this structure, and you should be able to now graph the tangent function just using that. So to recap, these points you can easily find by using your unit circle at pi over 4. Our tangent, the period for the parent function of tangent is pi. And this means that it usually ranges from negative pi over 2 to pi over 2. So using this information, we're now going to look at a problem where we will graph tangent with some transformations. All right, let's look at an example. We're going to apply our transformations, and I recommend that if you're still having trouble with transformations, just refer back to the sine and cosine video. But in this case, we have 2 times tangent of pi over 4x plus 1. Now, as always, start with your midline. In this case, it is y equals 1. So 1 here. I'm going to draw my midline. You'll notice it's going to be a very similar procedure to when we graph sine and cosine. I'm going to draw my asymptotes, which you remember are at pi over 2 and negative pi over 2. Now, just to quickly illustrate why we have those asymptotes, I think I missed it in the previous clip. At pi over 2, sine of pi over 2 is 1, and cosine pi over 2 is 0. So when I do that division, I get undefined. Oh, we have asymptotes there. Quick little side note. So if you remember, I'm going to do this again. Here on the side, our tangent function, or parent tangent function, does that. It has a point at the origin. It has a point right there and there, which is pi over 4, comma 1, and negative pi over 4, comma negative 1. That's where the sine and cosine equal the same value. When you divide them, you'll get 1 or negative 1, depending on the sign. So then, using this, you can do this in a few different steps, however you feel more confident in. But we know that we're going to have a point at our midline, right at the middle of the graph. So I'm going to place a point here, which is this point here on our graph. But now it's shifted up one. Now, before we move on, we need to change the scale. We need to change these numbers here because this coefficient changes our period. So if you remember in sine and cosine, we divided 2 pi by that coefficient. In this case, since tangent is only periodic over pi, so it only takes pi to repeat itself, we can do pi divided by pi over 4, not 2 pi divided by pi over 4. Now pi over 1 divided by pi over 4 is the same as pi over 1 times 4 over pi. Pi will cancel. My new period is cosine. And this is where it gets a little tricky. Label these. So I would pay extra care here. Our parent function has a period of pi, but this is half of that. And this is half of that, because then this whole thing is pi. So now, we just have to adapt our graph to showcase this with the new period. Instead of pi, now 4, which means if I split that in half, this is no longer pi over 2, it's no longer negative pi over 2. This is now negative 2 to positive 2. Because now my period is 4, and I go negative 2 to positive 2. Let me erase this, erase my map. You can always refer back to it. Great. Now we need our last few points. So we need to get these points. So always work from your midline. In this case, this 2 is telling us we're going to go up 2 instead of up 1 like we did in our parent function. So I'm going to go 2 and 3. And then I'm going to go to this midpoint there, which is 1. Right, that's where half. The now I can simply go up to and place a dot at my midway point between center to the edge. And I'm going to do the same thing, except I'm going to go down to place my next point. -1, comma, -1. My last point right there. Finally, follow the shape. You get your tangent function with some transformations. Now, I'm not going to showcase this with negatives or shifting it left and right. That still stays the same exactly with sine and cosine, so I recommend you go back to those and see how I shifted them. If it's negative, you just flip the graph and everything else stays the same. Next, we're going to be actually looking at how to graph cotangent, which is also a little tricky, but just a few steps you can easily do it. All right, now we're going to look at graphing cotangent. And cotangent is just the inverse of tangent. So it's just cosine over sine instead of sine over cosine. Up on the screen, I have tangent, one iteration. And I have the asymptotes in these dashed red lines and the midline in green. So let's look at cotangent, and here's two periods, two iterations. And we're going to notice some key things. I'm going to point them out, and I'm not going to explain so much why these things happen. You can always do your own research. But just key points to realize in order for you to graph cotangent. The first thing to notice is our asymptotes have changed. Now, these asymptotes have specifically changed where our points on our original graph, our tangent graph, touch the midline. So, for example, I'm going to graph a tangent here, but I just made 3 periods or 3 intervals instead of 1. So at any point that I touch my midline, you can see here, those 3 points, I'm actually going to now convert that to an asymptote. So we'll draw these in blue. There are our asymptotes now. And now, anytime our asymptote from tangent, the red lines, intersected with our midline, the green ones, we're actually going to have a point there that our function is going to go through. So I will put that in red. Finally, and so we're done with the asymptotes. I'm going to erase them so we don't get confused here. So these were the asymptotes for tangent, so we don't need them anymore now that we have our points. There we go. Finally, anywhere where I had my other 2 points, my other 2 key points, in this case here and here, we're still going to go through that with our cotangent graph. So I'm actually going to fill those in. Okay. You essentially follow the same order. Now that we have that, we're ready to graph. I guess one last point is this point also translates to here. Point. So those are our 3 points that we need. So now that we have that, we are ready to graph our cotangent function. So I'm actually going to deselect this, and I'm just going to connect the dots of my red lines passing through the point. Red line passing through the point. And to check our work, let's check what Desmos says. Now it's a pretty good graph that we have right there. You can see it follows the same pattern. Now we have graph cotangent. All right. So for this last clip, we're going to look at graphing cotangent with transformations. Up on the screen, I have that first problem we did where we graph a tangent with transformations, and we're just going to convert this to cotangent. So if you're ever given a cotangent equation to graph, first graph the tangent version, so the reciprocal, same thing with sine, cosine, secant, and all that, and then apply the rules we just learned. So for the sake of making this prettier, I'm going to replicate this curve like this. You'll see why in a minute. Right? It's periodic, so it's the same exact thing. And finally, we have it up there. So there's our tangent curve, just over 3 periods instead of 1. Now remember, anytime our graph, well, let's start off with this. Whenever our tangent line touches the midline, we actually turn that into an asymptote. So here, here, and here, we have asymptotes. Let's draw those in. Now we'll draw these in black. There's one asymptote, another asymptote, and here is our last asymptote. Great. Now, our second rule was anywhere our asymptote touches our midline, we are going to turn this into points. So turn this into a point and turn this into a point. Go ahead and do that. There are 2 points there. Finally, the last points we actually keep, we use them, we reuse them. So that means that we're going to use this point and this point, and we are going to use this point and this point. Okay? After that, we have everything we need ready to go, so I'm actually going to erase these asymptotes because we no longer need them. Just to make this a little nicer. Our midline, we can keep, but I'm just going to erase it. Our original tangent function, we no longer need. So going away too. And we're going to do the same thing on this side. Get pretty messy, so I recommend you do this in pencil. This point is no longer there because that's an asymptote. And we are ready to go. Just connect your new points and relate them to your asymptotes. And now we have graphed this cotangent function with some transformations. And again, if you were to move this left and right with that shift, you would just move this left and right. Okay. Other than that, that's pretty much it. I think this is probably one of the trickier ones to graph. So just, take your time, really ask yourself those questions, label everything, and you'll be all set to go.